before we move on, I would like to introduce Yuchu. Yuchu is one of our newer PhD students who've now been working with us for 8 months. And she is working at Volvo Cars. And one of the topics that she's been looking at is how can you do A/B testing in an automotive context? And that's where her presentation will be about. So Yuchu, please.
I would like to talk to you about a very important question that is very scientific. It's called if size matters. So it's for the context of A/B testing, obviously. So I don't think this remote works. There we go. My name is Yuchu. So just to get it out of the way, it pronounces as Yuchu minus the BE. I'm an industrial PhD student in Volvo Cars, and we are looking into how to enable A/B testing in the automotive domain. That is in the embedded software. And coming with embedded software, you have a unique set of challenge, as many of you may know. And today, I would like to talk to you about how to run A/B tests when the sample size are limited. And that includes how to utilize pre-experimental data and how to run this test on a very extremely small population. We had 28 cars. And then how do we increase the experiment sensitivity, i.e. the detectability of treatment effects. And so why do we even talk about A/B testing on small sample sizes? The reason is that if you randomly split A and B groups, you introduce two different variants to the group A and B, and then you purely measure their response, you're actually relying on the A and B groups to be extremely large groups. And the smaller the samples are, the larger the statistical variance will become. Thus, the actual treatment effect might become undetectable, and you're just wasting time and money running experiments that cannot be used. And we have very good examples from internet companies that they have actually been reporting challenges in obtaining large enough samples for their online experiments. So in Microsoft, 1 out of 3 experiments need to be re-randomized and rerun due to the undetectability of the treatment effects. And just to give you an idea, Netflix had reported around 200 million users in 2020. And we, as Volvo Cars, we have sold 600,000 cars in 2020. So we are orders of magnitude in terms of available users that we can run our experiments from. And on top of that, just to compound on the shortcoming, all the cars or all the vehicles, they have top hat, powertrain, sales market, and customizable options that further limits how much directly comparable variants we have out in the field. So let's run an example that is a little bit more relatable in the vehicle setting. So let's imagine you have a battery electric vehicle. To stay competitive, you would like to have high energy efficiency, and that is your target variable. And what influences is that besides the software and the hardware, it's, for instance, the weather, trip distance, trip frequency, average speed, so on and so forth. And now we call these covariates. So they are compounding factors that influence the target variable that is undesired, but you cannot control in a A/B testing kind of setup. And now that you introduce a new software that developed by some genius in the company that is supposed to aim to reduce energy consumption for this car, but how can you conclude that the energy consumption reduction is coming from the software, but not from the weather change? And so what we introduce is a method called the balance match weighted design method, the BMW method, but we do not abbreviate that for obvious reasons. And what that does is that it allows you to form A and B groups of a similar empirical distribution. And after you apply treatment to group B, you can safely conclude there's a causal effect of the treatment to the software change, to the effects that you are being measuring. And we do this method so we can produce similar group A and similar group B. We call that similarity a balanced group. And then since the group A and B are similar, so we can directly compare their treatment effect. And this kind of method is applied prior to running the A/B experiment. So you observe the cohorts for a certain period of time, you design your A and B group, you apply the treatment to the B group, and then you measure the treatment effects. And what happens is that the graph went away. So we run this balanced match weighted design method on 28 plug-in hybrid cars. And these 28 cars belongs to what is called a co-development fleet. So they are driven by our employees. And then we are A/B testing a software which learns the route choices and then optimize the electric and chemical energy distribution along the predicted route. So it actually, in contrast to a rule-based optimization that is already in the car, the B variant is a prediction-based optimization. And then we observe these cars for a continuous of 20 period, all the cars on software variant A. And then we apply the group design method, the BMW method, from the data collected. And then we introduce the variant B of software to only 14 of the cars. And what happens is that you could see this empirical distribution of the target variable when the groups are split at random to your left, and when the groups are split with the BMW method. And you could see that before the treatment is applied, the empirical distribution of the fuel consumption is incredibly similar for group A and B, which means that after the treatment is applied to group B and we see a shift in the distribution, we can conclude that the shift comes from our software change. And we have found a 34% more detectable treatment effect for the matched group in comparison to a paired group. And we have also found a almost 18% less mean square error for the matched groups. And so we recommend that you follow these 6 steps when applying the BMW method to a small sample group. The first step is obviously to determine which users are eligible and what variables you want to measure. And you apply these variables and then you measure the user for a certain period of time. You predetermine that. And then you select the input feature that is to be included in the BMW model. You run the model and then apply the treatment and collect the target variable. And in the end, you analyze the experiment. So it's fairly straightforward kind of process. And then we have done this process for observation period of 20 weeks and experiment period of 2 weeks. And we have found that this process or this method can effectively enable small-scale A/B testing. And then we can conclude a causal effect of treatments, which is a very powerful tool. And it allows us to easily implement it and then run A/B test even when you only have 30 or 28 cars. But of course, the certain limitation implies that we need pre-experimental data, implies that you need access to the vehicles or to your hardware or to the devices prior to the experiment. And you need to be sure what variables to include, because we can only balance variables that are observed, not instead of if you split at random that you are balancing all variables. And if you're interested in formulas, as David has previously mentioned, this paper will be appearing as EAA. And I promise you, there's only 4 formulas, so it's nothing intimidating. And with that, I'd like to thank you very much for listening. And if you have any questions, you're welcome to ask them now, or find me on LinkedIn or drop me an email. Thank you.
Very good. I hope
I don't bite, so please don't be too scared.
So let me grab my computer and make sure that I can see what's going on. Sorry for hopping in and out of the picture. But I believe that this is a quite interesting case of how to apply A/B testing in much smaller scopes than what we have traditionally seen in the past. So I was hoping to invite some people to ask questions. Any questions from the audience?
I think everyone is tired and looking forward to the coffee break.
Yeah, but we won't be serving any coffee. They have to get their own coffee, Yuchu. It's fun to have you here in the studio, by the way. It's much nicer.
It's like a podcast.
Exactly. If there are no questions, I may ask you a question. So what is next in your research, Yuchu? What are you going to do next?
David and I will keep looking into the similar topic, but with Bayesian statistics instead of frequency statistics. And we're going to look into the setup where you have the entire co-development fleet at your disposal that you could change the software of, and then you can measure the entire customer fleet of this 600, however many thousand cars.
Right.
And then how do we then compare these two fleets, and how do we run A/B testing in that kind of setup?
Right. So it's really a difference in the number of A alternatives and the number of B alternatives that you have available. Yeah. That's really exciting.
You could consider that as like a gradual rollout of A/B testing in a way.
Yes, exactly. Wonderful.
Thank you.
With that, I think we are back on track. So I hope that microphone is off. And thank you very much for a very efficient presentation, Yuchu, because thanks to you, we went from being a few minutes behind to being fully on time.